to all the people, desperately waiting for the next Kojo Bailey upload. I went to Dublin. It was a crazy experience. I'm sure Dublin's nice. Like, it might be a place I want to live someday, especially because like it's in the EU. It's like nice and UK-ish like in terms of weather, and because I do actually not mind UK weather too much, and it's like a good tech center and all that. But when I went with my friends the past few nights, it was terrible, man. Such a bad experience, and like not like necessarily because like Dublin sucks, but just because like we just got really shafted, honestly. Like, no free tap water in a lot of places, which is really unfortunate. I don't know why that's somewhat a thing. My fucking Lidl Plus got declined, which is like great. I mean, Tesco worked, Tesco Club Card, but the Lidl Plus just doesn't work across borders apparently. But like, those are minor things. One of my friends was like walking alone and like daytime, like in like a public space, but like it was fairly empty, and like some teenagers pulled up on him on scooters and like threatened to pull out a gun on him. It's like, what? Like, what's going on in Dublin? I thought it was Dublin, not America. Jesus. And we tried to go clubbing, but we couldn't get into any clubs for free. And like the ones that were free entry were 20 plus only, like 21 plus, 23 plus. Like, what the fuck? Why? And the ones that were paid were like €15, and we didn't want to pay €15 each to go clubbing, like not knowing what it's actually like inside, because like they're pretty empty as well. I mean, I guess like the end of the school year, so, or like end of the university year, so like there aren't as many students around. But like, Jesus Christ, like not a single place. Like Liverpool still has stuff going on. And this was like a Saturday night too, so like, and then on the way back, well, we were going to go to our ferry on the way back, but then our car got clamped because we parked in a no can do zone. We missed the signs as well, but whatever. But then like, because we got clamped, the car got moved, and then to get onto like, rather than just like giving a fine, like a parking ticket, whatever. It was clamped, so then we had to get it unclamped, but it took so long to get unclamped that we couldn't get on our ferry, so ended up missing the ferry. It was just it was just absolute disaster. Anyway, that's why I haven't recorded anything in the last 3 days. 3 or 4 days. I guess 4 days. 6, 7, 8. Yeah, 3 days, because today's the 9th, and I'm making this video. So, in a previous video, I talked about how I needed to update my Obsidian. Launch Obsidian first. I restarted my computer because my camera was tweaking out, but I figured out why it was tweaking out, so now it's all good. Turns out my camera can go much higher quality than what it is right now. Like right now, what you're looking at is 480p, but my camera can go to 720p. But it's just really laggy for some reason. I guess because my computer kind of sucks. But anyway, I got this inbox thing. Sorry, my Zettelkasten inbox for Obsidian, like notes to add to my Zettelkasten, are really... It's quite big. So I want to watch the C++ documentary. I'm aware it dropped. I haven't watched it yet, but I want to watch it. But I can't watch it until... Well, and I want to watch it until I finish going through this, like to clean this up, and also to finish this video I'm watching, which is a Bjarne Stroustrup video. Interview. It's about 2 hours long. I'm already like halfway through it. I'm way further than 48, but... Once it loads, or doesn't, but it's here. This one.
One of the people from Bell Labs came around.
Yeah, Crazy Plus. So this one. It's an interview by Ryan Peterman from 3 weeks ago. Before I watch the C++ documentary, I just want to finish this video because there's some really good notes to take on it. I haven't recorded this one yet. I was taking notes of it. I was taking notes on it in my own time, but now since I'm here, I want to do it now. Yeah, honestly, this channel is really cool. This guy does some really good interviews. Like, so far, I've loved this interview, and I think he does a good job at, asking the right questions and that. So I will save some of these as well for future. They are quite long, of course, but that's fine. I don't have an issue with that. Yes, we got the cookage of Haskell. That's very cool. P versus NP. This one I might have a look at, just to understand more about the P and NP argument, or discussion, whatever. I know I know about it, but I haven't really gone that deep into computational theory and all that. Dropbox guy, Harvard University. It's really cool that he got Bjarne Stroustrup. Bjarne. And even cooler that Bjarne says yes to these things, because he does do quite a lot of interviews, and I think it's really good because he has some good stuff to say. This one sounds interesting. Dijkstra, data abstraction, distributed systems. That was a bit shorter, might be interesting. AWS, Meta, X-head of Instagram. That's crazy. Yeah, really cool channel. Some really cool interviews. Of course, the most popular videos are stuff like AI and business, the business side of computer science, which I don't care about. I want the computer side of computer science. But yeah, there's Bjarne. Anyway, I'll have to look at these later maybe. Ooh, this is cool. If I'm not smart, I have the gift of abstraction. That's a good quote. Anyway, so I guess since I haven't shown this before, some highlights from this video so far. Really, I'm just like taking notes on things I learn or find interesting. I'm not taking notes on like on everything. Like just as the things that I care about. So Bell Labs was placed for was the best place. So I didn't know this, but Bell Labs was apparently back in the day was the best place for applied math and engineering. A bit like how MIT is now, or at least a few years ago, was considered the best. I'm sure it still is, but I feel like MIT's reputation isn't as high as it used to be. But I might be wrong about that. Maybe I just feel that way because now I'm in university myself. And also in Bell Labs, both Unix and C were developed. I knew that C++ came from Bell Labs because Bjarne talks about it a lot. I kind of knew that C was also in Bell Labs, but like I do forget sometimes that Dennis Ritchie and Bjarne were literally in the same department, or like same university, I guess. Is Bell Labs university? I guess it was, right? And then Unix as well. I did not know that Unix came from that, so that's really cool, because of course Unix went on to inspire Linux, right? Which is written in C. And then Bjarne wanted a language for distributed Unix. I think this project failed, but he needed low enemy memory access with C, but then high level abstraction like Simula. And so you get C and Simula cross to get C++, right? C with classes. Bjarne got his PhD from Cambridge, I learned, which I didn't know. And I think he still teaches at Cambridge, or at least used to, as a professor, which is really cool. Maybe one day, if I go down the computer science route, I can go to Cambridge for a PhD. I do actually wonder what he did his PhD in. I do want to look into that. So actually, just reading this, I'm gonna add a question. What was his PhD in? And what research papers has he written in general? Because like when I look at like computer science research papers, it's a lot of like theory stuff, like theory of computation, like AI stuff. I don't really care about that. I care about like the actual programming side of things. So I wonder what PhDs there are in that area. Like Bjarne made a programming language, right? So surely his would be surely he would have some interesting examples. He tried to make a simulator in Simula, but it wasn't very memory efficient, right? He needed the memory efficiency of C. And because it wasn't memory efficient, it got him kicked off the uni system. So he rewrote it in BCPL, and it was 50 times faster, but it was also a pain in the ass to write, he said. So he vowed never to do that again with such primitive tools. So of course, when you get a person, an engineer, who is trying to work with not very nice tools, what do? They will create better tools. So all of these were without any timestamps. But then I started adding timestamps here. I know it looks like this is like a summary or something. This isn't. This is just me forgetting to, or not bothering to add timestamps until later, because I was eating at the same time. So then we get Dennis Ritchie's section. I didn't know this. Apparently Dennis Ritchie pointed to C++ as the obvious successor to C, which I think is really cool. Like C++ got C's blessing, you know? Like Bjarne talks a lot about like how stupid the language wars are. Really, like C++ and C, like, I mean, there are arguments for like, okay, but if you use C, then you don't have to like deal with all the bloat of C++, but whatever, man. Bjarne says, yeah, I didn't know this as well. a lot of people dog on C++, right, and say, oh, whatever. But people don't know that Bjarne is literally, like, he contributed a lot to C back in the day. Like, a lot of the things that are in C were literally contributed by Bjarne, and then therefore in C++. So, like, C++ has also influenced C in ways that people don't really appreciate enough when they dog on C++. I mean, again, like, as these guys say all the time, like, the whole language war thing is stupid anyway. Like, we shouldn't be fucking, saying, I hate this language, like, we should be looking at the language and say, okay, well, this is good, this is bad, and I can see, like, the benefits of it, rather than just like, oh, I love C, I'm gonna stick with C my entire life. Oh, C++, fuck that, too bloated. Zig, fuck that, it's too un-C-like. I don't know, man. Yeah, this is interesting. So, also, Dennis Ritchie. And by the way, it's cool that in Bjarne's interviews, you also learn a lot about Dennis Ritchie and other people too. Despite developing C, because Dennis Ritchie wasn't part of the C committee, he wasn't he was literally disregarded as a C expert, which I thought was really weird, and just really really silly. I don't know what to say about that, to be honest. Dennis proposed a fat pointer, but it wasn't as the early C because it was 2 words, right? And now it's in C++ as standard span. I said Dennis proposed a fat pointer. I don't know if it was Dennis or Bjarne. Let me actually just check that, because that doesn't sound correct. But if it was Ritchie, then I'm even more surprised. So this was on 21/13.
Exact. And so in there was one anecdote about Dennis Ritchie. It was about this concept where he proposed to the C standard committee this idea of a fat pointer.
Oh, that's right, you did.
Where it also has it stores its size as well. And you mentioned the C committee didn't approve. I was curious if you could tell that.
So Dennis did C, but he didn't take part in the standards committee. And I've even heard people from the C standards committee say,
okay, I'm too far.
Anyway, is to use what Dennis called a fat pointer, which is a pointer with its number of elements it points to attached to it. But that's 2 words, and that is why it wasn't used on the early C, because then they had 48K of memory, and when I...
That's crazy. So basically, Dennis, it was Dennis, he proposed a fat pointer, but it was rejected from early C because it was 2 words. So they just didn't add it, and because of that, C now has it doesn't have fat pointers, does it? Maybe it does through some other means now, but it was part of standard span, which, by the way, only came in C++ 20. Can you believe that? Standard span, a feature that was initially proposed all the way back in C's foundations, it was only eventually added in C++ 20 to the C++ standard library. That's C++. As far as C goes, you can make a fat pointer, but yeah, I mean that is crazy to me. I thought, by the way, looking that up would be C++ 11 or maybe 17. 20 is insane. Also, Bjarne talks about imposter syndrome, and he says that he still struggles with it to a degree, which I think is very cool. Very, very nice for him to be real about that. But he was literally surrounded by so many great people, like fucking geniuses, right? So he was able to learn a lot from them by talking to them, which is really cool. I'd love to find myself in a place someday where I can just talk to people who are just really good at what they do, and have really interesting projects. I'd love to talk about that to people about that. And there was an unspoken policy in Bell Labs that everyone had their doors open so that anyone could just walk in and talk to them, which I think is also a really cool culture. Yeah, I hope there are still places on Earth like that to this day, Bjarne says that he wasn't able to build the C++ he wanted initially, right? The modern C++, especially with upcoming features that aren't in the language yet. I know a lot of people complain about C++ and all that, but a lot of the features that they're adding are actually fixing a lot of the issues and making it a lot nicer to use. And some of these features, like I believe contracts, were things that Bjarne wanted to add all the way since like the early days of C++, but he wasn't able to, partly due to technology limitations, right, obviously, but also because he was inexperienced, and he does actually acknowledge that, which I think is really cool. Hence, C++ is going to be so big today, right? Like big, like physically, like it takes lots of fucking space, and people call it bloated. But you know what? It's better to have too much than too little, I'd say, as far as like tooling goes. Because like the bloat isn't like bloat in your program or like bloat in your code per se. I mean, like maybe some like names are long, like the syntax is like a bit bloated, but like the actual like bloat that people talk about with like C++ has so many features, you know, the library is massive, standard library is massive, like that bloat doesn't make its way into your program unless you opt into it. So is that really an issue? I think it's better to have that than to have a language that has, you know, nothing or a lot less. Yeah, like this also like really stood out to me because like when you are inexperienced, right, you want to do the best you can in that moment, but it's impossible. Like there'll always be things that you just overlook. It's why I don't think the Zig has a particularly great model with wanting to like reach perfection or like close to perfection before releasing 1.0. I think that's a goal that won't really work in the long term. I think what you really need is a way to have additions like Rust, because you're just gonna have developments that are just that are unforeseen, and you'll want to make major changes that break old things if you can. You know, like if you can have a system set up such that you can afford to make breaking changes in the future, you know, like safely, let's say. Yeah, Bjarne supports DSLs, which are domain-specific languages, which I think is cool. I mention this because there are a lot of people who like really only care about general-purpose languages and think that DSLs are too limited. But I think DSLs are, when used correctly, have their right use, right? But like, don't just make a DSL for the sake of making DSL. Like, make a DSL specific to a problem, which means you need to first identify the problem, which is also very important. C++ was made C compatible so that it would be easier for people to adopt and take advantage of existing tooling. Obviously now there's C++ has its own tooling, right? But yeah, the fact that C++ was C compatible was really important, and it also led to, you know, like it's a reason why C++ has so much baggage from C. A lot of the issues that people have with C++ are actually issues with C, and they wouldn't exist if C++ wasn't backwards compatible with C. But yeah, it's interesting. Like Zig, one reason Zig I think is so, or like an advantage Zig has over other languages is the fact that it can cross-compile with C and maybe C++, but mostly C very easily. And of course, C itself is also just very easy to interop with. Like it'd be very hard to make a language that can easily cross-compile with C++, because the C++ ABI is kind of messy. But yeah, that's good to take note of. People call C++ object-oriented. Bjarne disagrees. Sorry, he never called it object-oriented. He only said that that C++ supports object-oriented programming. I think that's what he said. Or not even object-oriented. Like he said, it supports objects. Like back in like an old C++ book or a specification. Somehow then this grew to people saying, C++ is an object-oriented language, even though it's not. Java is object-oriented. C# is, well, at least was object-oriented. I don't know if it still if it still necessarily is, but like C++ definitely is not. You do not have to use classes, and you don't have to use objects. Like you can write C-style code in C++. It's not object-oriented. Yeah, he prefers to call it class-oriented or type-oriented. Why? Because a lot of C++ is focused on making your own user-defined types. And this, again, is not just for classes. It can also be with concepts and other abstractions, which are really useful. This is so interesting. For complex numbers, he wanted native complex number syntax. And to achieve that, you need to have, like, you know, operator overloading and stuff like that, right? To have, like, 3 plus z as opposed to z add 3. So that's interesting. Bjarne hates debugging, of course, and so he said that he prefers. I mean, I say of course because who doesn't? And well, I guess some people like it, but like he wants to write the program, not debug the program, and so he likes languages that, you know, like help the user spend less time debugging and more time actually designing the program, engineering. So because of that, I think like he actually probably does like Rust, or like to that extent. Maybe not so much like the strict safety of Rust, but definitely like the way that the compiler can help you. I think he very much would like that. And it's why the C++ type system is so much stronger than C's is, right? Or at least C's used to be. I think C's has developed over time, and Rust has an even stronger type system, right? He's in favor of compile time resolution of bugs. Yep, and acknowledges that although that means that compile times are longer, you're also compiling less often, which means you are ultimately saving time on compilation, which is also true. And again, just another reason why I think he would like Rust. So I really want to hear Bjarne talk about Rust, because I haven't heard him even mention Rust really before. Even though like the language is very interesting as a competitor to C++. But yeah, like there don't seem to be any particular interviews where he talks about Rust, which is unfortunate. I would love to hear him talk about that. Also, I need to look at these CPPCon videos really, because there's some really good videos here. I'm gonna save this one to watch later. Like there's just so much wisdom to get from these people, Bjarne attributes the issues people have with memory safety in C++ to not using modern C++ tools. Yeah, a lot of people have issues with C++, but they're using like C++ 11 or like 17 even. Like make use. Like if you are compiling your own project, you have no reason not to use the most recent C++. If you can support it, use it. Like there's such great features in C++ 26 and upcoming. 29 has like pattern matching plan for it and stuff like that. Like use them. Like yeah, like Rust is competing and makes C++ look so primitive. If you only like compare Rust to C++ from literally 15 years ago. Like use the modern C++ tools. Yes, C++ is playing catch up in some areas, but like it is playing catch up. Like the features are coming to C++. It is an evolving language, Profiles is a feature that Bjarne is working on, and I'm really interested in that. Bjarne has a proposal for C++ 29 for the compiler to be more strict and disallow programmers from doing silly things by default. I think that's very smart, because although the language itself can't change, the compiler can definitely change, right? So if you just have if you move a lot of the development to the compiler as well, to having the compiler be supportive, then that's fine. That shouldn't have any backwards compatibility issues per se. And of course, it would be a default, so you could disable it, right, if you want to. Because the default should be good. And although we can't change the language defaults, we can change compiler defaults. That's easy. Been a bit of the Senate committee. He claims that C++ was never a dictatorship. I said claims because you always have to take the words from the person saying it's not a dictatorship with a grain of salt. Although I do believe it in this case, but like just for out of habit, right? Of not like taking fact from statement, like not confusing fact from statement. He didn't choose for there to be a science committee, and he wanted to be under control of the community, which I think is very, very cool, very interesting. But it seems just wouldn't have taken off, he says, if it wasn't standardized by a company like, in this case under ISO, right? So there are people from IBM. He said like they like twisted his wrist or whatever the word is, like twisted his hand, like metaphorically. To really push for there to be a standard. And he's grateful for it being standardized, but at the same time, if it was to be under control of the community, I wonder how that would have turned out. Because like, Zig has a community, I guess, but you still have, what's his name? Andrew whatever, I forgot his name. He's obviously behind that. And for Rust, you have the Rust Foundation, right, which isn't community driven per se. And yeah, and here, like he says, if C++ had not been standardized, it likely would have faded out of relevancy. This is also interesting to me. When Bjarne saw people claiming that Java would absolutely kill C++ in 2 years, that's what he his quote was. I don't know why I have double quotes within a quote there. He thought it was rude, and I think it's interesting that he says it was rude. And ironically, it didn't work. Because like now C++ has like 10 to 12 times as many programmers now as it did back then. So C++ has only grown massively in popularity as opposed to being killed by Java. And now Java is a bit of a laughing stock, like if you ask people what are your least favorite languages, or like the worst languages, like actual languages, not like brainfuck, people would probably say JavaScript or Java, because those languages are not the nicest, to be frank. I know Java has come a long way with like its recent updates and stuff, and it is honestly a lot nicer now. I mean, again, like C++, it is also an evolving language, but like just the fundamental design flaws with Java, they do stand out. And same with C++, but like C++ will always have the benefit of just being a memory systems programming language, right? Like memory focused, that also supports abstraction. Whereas Java has a garbage collector, and uses like the JVM, and it's a very different world. And you know what? Java works well for lots of things. So, but anyway, what was interesting for me there was that he said it was rude. Like almost like it was hurtful. Like, okay, like fine, like maybe a language will come and be better than C++, but like what are you saying? You'll absolutely kill C++ in 2 years. Like, okay, Jesus Christ. Like imagine if you're like I don't know. Imagine if you have built, like, engineered this invention that helps humanity, and then some other invention comes along and says, "Oh yeah, we're gonna kill your invention in the next 2 years. Watch out." It's like, okay, like that's not friendly competition. That's just straight up being a jackass. And the same thing goes for programming languages, which is why these language wars are so dumb. Like, people should just be a bit more collaborative. And again, the irony is that it didn't work. C++ is still very popular. So like, no, it wasn't rude, but it was arrogant, for no reason. But yeah, that was interesting to me that he used that word. And they went on to say how the C++ Standing Committee is underfunded, or even you could say has no funding, full stop, which I think is very interesting. I did not know that. I thought they got like money from companies and stuff. But the fact that it's underfunded is really interesting, and I wonder if, well, I wonder if that that probably is the reason why C++ development has been slow. Like, again, like pattern matching was moved from C++ 26 to 29, and even saying that, it's now 2026, and a lot of features for 26 have not been implemented yet. Like, we still don't have like proper module support. Standard float is an issue I had, where that isn't implemented on Clang. And it is for GCC, but it just uses like a fucking definition, like the macro, as opposed to a proper implementation. So it's slow, which is unfortunate. And it doesn't help that C++ itself is also a very slow... What the hell? I didn't open this. That C++ is slow to develop because of how much baggage it has, historical baggage it has. And then here, consensus is important when adding in features. Because, yeah, so this was interesting. He said that it's good to have strong consensus within the committee, which is why he aims for like 90% or higher. And then he starts to worry when 80% of people agree on a feature. Because what you don't want to have is like the language branching off in different directions, where like this team of people go and create C++, I don't know, or like C, or like fucking D or something, I don't know, right? Like, you want people to stay on board with the main project, because then not only do you spawn less competitors, and like competitors are good, but obviously if you you would prefer if they helped you and like use their differing views to help develop that your language be better. So like it's important to like be able to have that collaboration and like actually talk through problems and like agree on what would be best. But if you have like people who are disagreeing, then not only do you get competitors who are going to like whatever, which like again, it's good for capitalism. It's not so good for you as a language who has to compete, because like it's like a pressure, right? But then also you lose developers who were working on your project, so then you're understaffed, right? So I understand that too. It's very interesting, and I wonder. I'm trying to think if that's like happened before with languages. Obviously it happens with like companies all the time, like Claude. Whatever they're called. Claude is Anthropic, right? Anthropic were originally a team of OpenAI people, whatever, and like then they left. For languages, C++. I mean, like C, but like although C++ came from C, or like came after C, it wasn't like Bjarne was like never working on C. He just wanted to make a language that was like C, but just had like more abstraction, which is like probably pretty natural. Rust, I don't think has spawned any particular like clones. The thing is though, like they probably have spawned like other versions of themselves, but those versions just haven't really kicked off. In history, I definitely can't think of a case where a language has branched off of another language because of disagreements and then gone to become more popular. That I haven't heard of. So, but maybe I'm wrong. But anyway, enough yapping there. Let me then continue. So I was about halfway through on 5615. Again, it's quite a long video, but it's a very interesting one.
C++ Standards Committee had 527 members, and we work on consensus, because if you don't have consensus, then you get dialects. We don't want to have a feature in that's voted in, say 60 to 40, or even worse, 52 to 48 percent. We don't do that, and that's painful and tedious and good.
When you say consensus, that 100% need to approve?
100% is not necessary. We don't need unanimity. We need a massive majority, and basically I would like to see 90%, and we often do. 80% I start to worry. And
what's the lower bound that's coded into the rules?
There's no lower bound coded into the rules. The rule says that the convener of the ISO committee determines what is consensus. So pure numbers doesn't say it. Could you imagine you had a vote, 95% versus 5%, but the implementers of C++ compiler and standard libraries from Google, Apple, Microsoft, and others were all in the 5%. Is that consensus? I can reassure you that no convener would call that consensus.
So there is like, so it is, yeah. So it's not just a numbers game. It's very much like whose opinions are we actually listening to. I will of course make a connection between this and politics, real world politics, where I believe like the elections for, was it Trump versus Hillary, were like extremely close. Brexit was extremely close as well, I believe. Brexit votes. So, Brexit was 52 to 48. In fact, I wonder if that's what Bjarne was referencing there. 52 to 48 is not consensus. We should not have left the EU with a vote this bloody close. It is so stupid. And yet it happened. Because for some reason, fucking real world politics is absolutely ass. Like, systematically wise. Systematically. So that's what, right? That's a word, okay.
And that makes sense intuitively. I kind of wonder with democratic decisions, there needs to be objective rules. So, like, what if the convener made the wrong decision?
It happens, but you can't just have numeric rules. Not everybody cares for the whole language. Not everybody understands what's going on. You can vote at your third meeting, so you might have somebody with a vote that has 8 months of experience with the standardization and don't understand standardization and knows only what they known from their development organization that they've been part of, which might be a small one. You need some judgment, and you hope that the convener has that judgment. The convener always asks the national representatives. The other way of getting...
Yeah, it's a problem for... Because, like, a committee, ultimately, is a dictatorship, right? Like, the committee, convener, whatever, will decide what happens. It's sort of like an open democracy. We're like, okay, then, I guess we have to do this. Like, no, like, it is still technically a dictatorship. But, like, people, they just use democracy to kind of, like, gauge agreement and consensus. Whereas like in like real world politics, if you vote for your president, the president is the convener. Not necessarily, but I mean, because like there are like laws in place already that can't really be changed, like constitutions, right? Like those aren't people; those are just laws that were written down by the first people, right? So it's, to that extent, they are dictators. Like there has to be some like absolute power that cannot be overruled in a democracy. Yeah. And, like, when that's not a person, it's really hard to design a system where you can fairly, like, decide that. Which is why, again, like, countries fall back on democracy. And just, like, whoever has the most votes wins. Which makes sense for elections, by the way. But, like, for Brexit, like... there is still the Prime Minister and the other people in Parliament who should be able to make a more informed decision. So, like, look at the 48-52 and go, yeah, that isn't really consensus, is it? And, like, there's also political turmoil about this. People are not happy about this. And the people who do like it may not be educated, so let's not do it. Obviously, it's corrupt, which is why they allowed it in the first place. Because they kind of wanted it to happen, but...
getting a consensus is that you have a massive consensus, but you have 10 countries where the representatives didn't agree. That's not consensus. And even when there looks, if there is a... look, if everybody is for, if it's massive and all of that, there's not a problem. But if there's a problem, the convener asks the national body heads, he asks the implementers, sort of key people that are necessary for getting the voted change into real use. Sometimes educators also, before they make that decision. Not everybody weighs equally once there's a disagreement.
For this podcast, I produced transcripts for every episode for convenient skimming, and I built a custom tool to automate that. Recently, I noticed in the Barbara Liskov transcript, my simple speech-to-text tool was getting a lot of things wrong. For instance, the CLU programming language is spelled all caps CLU, not CLU. So to fix this, I used Cursor 3, picked the strongest version of Opus 4.7 extra high, and there's podcast. About the standards committee, I saw in some of your writing, you said one of the most negatively received ideas you'd ever presented was auto. And I know auto eventually made its way in there, but what's the story behind why it was so, negative?
That's interesting, yeah. Auto was quite hated, wasn't it?
Received at that time.
But it's a very useful feature. That being said, I only, actually I don't really use it. I mean, I use it to shorten long type names, Like if I'm returning from a standard expected function, I'll use auto in the same way that Rust developers don't type out the whole result type, they just do let, right? So like I only do it if it's that, or if it's really obvious what the return type is. Like if I have auto foo equals reads, and then like in templates u32, like it's pretty obvious it's a u32, so that's also fine, and I do auto there. And of course for trailing return types and functions, but yeah, I wonder why it was hated. I guess because like it makes things hidden, and like auto can be abused in a bad way. At which point it kind of just comes down to convention, right? But like there are conventionally good ways to use auto. But I understand why people would be fearful of it being used badly.
It was just unusual. People thought it was weakening the type system. And also it opens the door to fairly general generic programming that is not heavily syntax based.
Yeah, because you can use auto implicit templates, which can be quite... Well, I mean, like, I prefer not to, but you can.
And auto is the beginning of concepts, which is the ability to put constraints on generic code. And auto is just the simplest constraint. It must be a type, as opposed to a value 7. And maybe I didn't explain this well enough, and there's a variety of backgrounds in the committee, and maybe they didn't know languages of the generic types, ML, Haskell, things like that. So it was horrible. Eek! So anyway, we still got it because we needed something like that. But it wasn't enough. I have looked at industrial software and problems with overuse of auto. You should only use auto when you have an idea about what is needed there. It's good in generic code where there's you go and eventually you check the type is correct, that auto has resolved to something that supports the operations that you're going to do on it. And that's what concept formalizes. But it was always checked at the end. And I noticed a group of people that was overusing auto in a framework for networking. And they were saying that they were being slowed down, not so much with bugs, but they had to look up the functions being called to see what that auto could possibly bind to. And then they had to put in comments that says what
that's just bad code,
what the auto was meant. So you have auto and the comment says must be an input channel. Now you simply define input channel, and then instead of saying auto, you say input channel auto. Fine, that's what the system is. My design of that simply said that auto is the simplest concept, and you should simply only set input channel C equals blah blah blah. But anyway, the committee wanted an indicator that this was going on. Oh well.
I saw another anecdote in kind of the standards committee being heated at sometimes. You mentioned there's this thing about shuttle diplomacy between two corners of the room because I think it was IBM and Intel. They both needed different support. What's the story behind that?
I was actually talking to Brian McKnight, who was the IBM rep at the time, and it was last week. And we were discussing some of the things that was happening then. So it's still remembered. So basically, IBM was doing the what's that architecture called?
PowerPC.
PowerPC and
the x86.
And the Intel was doing, well, Intel. And they have different models of the underlying hardware, especially coordination with the caches and things like that. And basically, and the guy representing Intel wasn't actually an Intel guy. That was anyway. Also a good guy. I use some of his slides in my presentations. So I knew these guys, but they were totally deadlocked. I mean, these are
deadlock.
Massive organizations with massive amounts of code out there, and basically some things could be done, but the IBM guy, Brian, said that they had a lot of software, mostly in the lowest level, even down in the microcode, that was relying on the way they have done it. And the people who had done it had left the company. They was done a long time ago.
That's a problem, yeah.
And they just couldn't rewrite all of that code and get it right, even if the Intel guys was right. Okay. And the Intel guys had similar arguments and similar points. This is better. We are using
it. Maintainability.
And so I was shuffling. They were they were in different corners of a large room. And so I go up to the Intel guy, the guy representing Intel here, and what's the problem here? Tell me about it. Explain it. I go down, explain. He's saying this. They say, well, there's this, and I go back again. And I spent a couple of hours literally doing shuttle diplomacy, walking from one corner of the room to the other. And we reached an agreement, and that's in C++ 11. And a couple of years later, they both agreed that they were now using a combination of what they had before and what the other guys brought in. So the result was
cool.
Was improvement.
Yeah, that's cool.
Cross-pollination.
Ideas, yeah, cross-pollination.
That's funny.
Cool.
Why did you have to do shuttle diplomacy? Why not just a group conversation with?
Because they've been trying that for days and probably for meetings before that, and it didn't work. So I guess I was just translating and asking questions. I mean, those were experts. I don't consider myself expert at that level. I mean, I've done hardware, I've done microcode, so I'm not an amateur, but these guys are really good. So the IBM guy is now the guy doing most of the synchronization under Linux. We're still using his stuff today. He has a C version of it, so he can get it into but it's the bottom of the Linux kernel.
When I was reading your writing in these papers, there's this part where it seems like in 1995, you had this idea to introduce some form of automatic garbage collection into C++, and that kind of surprised me because when I think about C++, one of my immediate thoughts is no garbage collector. We're going to manually or manage the memory ourselves. How would that even work?
What the hell? I didn't know that. C++ automatic garbage collection.
There's two things there. One, I wanted to automate resource management in general, not just garbage, not just memory. And for that you have constructors, destructors, and the techniques those later known as RAII, resource acquisition is initialization, which is probably my worst naming ever. But I was busy at the time. So in the standards committee, those people that insisted that we needed to be able to do garbage collection. And there was garbage collectors out there. Oh, that was Hans Böhm. He was the one that represented the internal model of stuff.
People forget, you actually can write a garbage collector for your language, or like for your program, sorry, in like C++. Like, you can do that. It's just probably not the funnest thing to do.
He has a conservative garbage collector, still used today. And we thought we needed an interface so that it could be standard how you used such a garbage collector. And so basically I was listening to the users, expert users, and they thought it was necessary. I thought that support for memory management, resource management was important. I've thought that from the beginning. I didn't think garbage collection was appropriate for a lot of what I was doing, but certainly automating the management was ideal. And so after a long set of discussions, we found an interface that people agreed on, and we put it into C++ 11. And what we found was, over the next 10 years, the amount of usage of garbage collection decreased as RAII,
the point to was C++
resource management that had been there all the time, got more and better understood and was used more. Furthermore, the people who still used the garbage collectors didn't use the standard interface because they had figured out ways of doing it better. And so today there are still a few people doing garbage collection, but it's not part of the standard.
How does that work? Is it kind of like a wrapper around the memory allocation methods?
Yeah.
Okay.
You have a different implementation of new or malloc or operator new, or whatever it is you're using at your lowest level. And then delete becomes something slightly different too.
There's this cautionary tale in the C++ community about this ship, Vasa, and I was kind of curious, like, why that's popular. And
I've not heard of this.
We had a meeting in Stockholm at some point, and they have a wonderful ship that, if you ever get to Stockholm, you should see the Vasa. It's a battleship from the 1600s. There's a story to that, and that's the one I tell people. The king was ordering built a battleship that should be the best and most beautiful battleship around. It was going to be a good fighting battleship, and it was going to be used for diplomatic visits, so it should be beautiful. And they laid down the keel and they started building it, and then they heard that a likely opponent was building battleships with 2 gun decks. And this was a then old-fashioned battleship with only 1 gun deck. And if you put a 1 gun deck battleship next to a 2 gun deck battleship, the highly predictable result is a lot of holes in the 1 gun deck battleship, and it's gone. So the king orders that this ship should now have 2 gun decks. And they've already started building it. So they add another gun deck, they add cannons up there, and the king also wants, now the ship is bigger, they want more statues and beautiful things. So it becomes a bit top heavy. And rumor has it, I've never checked this rumor, so it might be wrong, is that the ship designer committed suicide out of horror. Also, a thing
it's
that
a true story.
I don't believe is just a rumor,
It's a rumor.
was when they was built, they tested it to stability. And the way you test a ship like that for stability is you take the whole crew and you run them from one side to the other. Back, forth, get harmonic there. And if you can do that 14 times, then it'll stand up to the Baltic and the North Sea. Rumor has it, actually, as I said, I think it's fact, that they did it 7 times and then they stopped because it looked dangerous. So, this was 1624, I think. The ship gets finished. It's sailing out, the most wonderful ship you've ever seen. It's sailing out in Stockholm Harbor, trumpets blaring, flags flying, families of crews on board, the whole thing. It gets halfway across the harbor, a gust of wind comes, it keels over, and it's gone. And it ends down in some place where there's not much much oxygen, so it was well preserved, and they fished it up again, and you can see it. And so
is this true or what? I'm very confused now. Stockholm sunken ship. The Vasa. Huh. So it is a real ship. I wonder how this relates to C++.
I tell this story to the standards committee, and I point out there's something they did wrong. They built more features on top without improving the foundation. Always improve the foundation to make sure that it's just not a random set of features that you have added, because that's complexity.
Right. Because again, people complain that C++ has so many features. If the features are not built off of a good foundation, or a foundation that's updated to withstand the new features, that causes issues.
Furthermore, do not compromise your testing. That's really dangerous. And
I mean, that was obvious, right? Like, if your tests are failing.
Furthermore, you've all noticed when your high bosses say something should be done, and the high bosses don't always know what's right. Sometimes the professional thing is to say, no, we are not doing this. We have to take it easy.
I wonder how that works. Like, in what situations is that not an option?
They had said, okay, we'll build a one gun deck battleship. We'll just not call it the Vasa. Call it something neutral. And then next year you can have a battleship that's been designed from the bottom up to be a 2-gun deck battleship. You wouldn't have any problems with that. But
it's a compromise.
The high management, meaning the king, who was in Poland at the time, so he couldn't even see it, says, nope, must be delivered on time. And so they delivered something on time that just couldn't do the job.
More of the story, deadlines suck.
But go see the ship, it's great.
But unnecessary. That is so interesting. So there's... Bjarne has told the story of the... Where is Stockholm? That's in Sweden, right? Yeah, Swedish. My god, bro. Ah! My keybinds, bro. My fucking... Why is it... Why...
One of the people from Bell Labs came along to give a talk. And the tradition in England and in the computer lab is after you wouldn't have any problems.
Right. Before I go any further, I don't actually have the thumbnail for this. So let me just steal this. So I swear I've seen this thumbnail picture before from Fireship. Of the Swedish Vasa, which sunk due to being rushed in development. It was originally built to have one gun deck, but upon seeing another ship with 2 gun decks, the king demanded that the Vasa also be given to midway through development, meaning the ship's foundation was not strong enough to support the 2 decks. Bjarne tells this as a cautionary tale of adding features without strong foundations, as well as for the importance of engineers refusing bad requests, such demands from their higher-ups, who do not understand the issue as well.
And the high bosses don't always the foundation. To the standards committee, and I point, so it was well preserved, and they fished it up again, and you can see it. And so I tell this story to the standards committee, and I point out there's something
cool
to be achieved, and see it. Says nope.
At some point, someone demonstrated that the C++ template instantiation mechanism was Turing complete.
Very interesting. Yeah.
So, what the compiler is going to do to kind of pre-process that C++ program can actually be used for computation. And I was just trying to understand how is that possible? Like how it was mentioned something about he calculated prime numbers at compile time. How's that work?
Well, the prime number thing was just a curiosity. It used the error messages to report the result. But when you build something, you can get Turing completeness. You need some form of iterate or recurse, and you need a comparison, and that's about it. Then you can get Turing completeness. And at least some of the theoreticians says, hey, we can't do that, it'll run forever. And the guy who Unruh, who came up with the first example of this, actually thought I should prohibit it somehow. I should ban it. And my reaction was, this looks useful, great. And I think I was right. Furthermore, nothing runs forever. If you have a Turing machine, you have the tape. And the tape has to be infinite. So if you imagine building a real Turing machine the way Turing designed it, you have to have a bunch of navies building track all the time when it gets out there. Of course we don't do that. The point is that the compiler will run out of resources long before we get into real problems. Machines are finite. And so the problem doesn't become real unless there's bugs. And the bugs get caught, guaranteed. So, not a problem. What happened, though, was that people were misusing templates to do simple calculations, like prime numbers or Eratosthenes' sieve, or calculating factorials and such. And it's so awful, and it's so expensive, and it uses up so much memory that it becomes a problem. So that was why I and Gabidus Reyes built constexpr, which basically says you can calculate perfectly ordinary code at compile time, and it is much simpler, much more what we're used to, and much faster to compile, and giving usually much faster code. And you have that today, and you have constval if you want to guarantee that this is done. And so that takes care of the obvious misuses of the idea of templates being Turing complete.
I've heard a lot of, not glaze, but like bravado. That's not the word. No. By the way, I've heard a lot of like positive reception to constexpr. People usually talk about it in a very positive light, and of course people would, right? In the same way that people are very positive about comp time in Zig. You know, it's one of Zig's most appealing features. That stands out against like Rust's way of doing generics. And like I say, generics, it can be used for other things too, right? And like templates were not designed or intended for people to calculate factorials, but the thing is you can, right? So constexpr, very cool, obviously. And I wonder, with reflection coming in C++ 29, 26, I can't remember right now. I mean, point is, it's not in the language right now, nor does it have a finalized syntax, I don't think. But when it is added to the language, I wonder if it will replace templates. Because templates, like, you know how Zig doesn't have templates, because Zig just lets you like pass in types as variables, right? Like as arguments. You will be able to do that with reflection in C++ soon enough. So once that does happen, I just wonder what effect that will have. Because templates will kind of become obsolete. So that'll be quite very interesting. But at the same time, like templates aren't bad to use per se, and like you can use them with concepts as well. So yeah, it is interesting.
It turns them into ordinary functions.
Generally, with programming languages, there's this high-level intuition that the closer to the machine you are, the higher the performance is. And I tend to see C as closer to the machine than C++, for instance. That's not the case.
It's not the case. It's not as good as compile time calculation as C++ is. And anyway, we have exactly the same machine model because C borrowed the C++ 11 machine model. So if you write the same code in both languages, you get the same result, except the C++ compilers can do more at compile time, and so C++ runs as fast or fast.
Oh, my brother's calling me. Hello? What? Your cameras are on. No, it's not. Oh. I see you. Yeah? No? Not for me. What are you doing? You stole Daddy's phone. You stole Mommy's phone. Alright, well, I'll call you back, Finn, because I'm busy right now. Just hung up before I could even say anything. All right. Sorry, abstraction performance. I also think of C as being more low level than C++, just because the argument is less in the fact that they compile to the same shit, but more into that your average experience writing C is closer to like conceptually to what a computer does behind the scenes than C++ is. Like, to me, low level just means low abstraction, pretty much, because like that's what it is, isn't it?
Faster than C in most cases.
Performance-wise, it doesn't matter.
There's more information.
That's a different argument. But like,
if you give the optimizer more
stuff.
information, it can do a better job.
Okay. Yeah, because that was what I was going to ask you. Was you had said somewhere that.
That being said, what I wonder is how abstract can you go? How much abstraction can you add to a system while keeping it low level? And that I don't know.
That C++ can be more performant than C, but I tend to think that more abstraction costs you something.
It's compiled away. This is why I talk about zero overhead abstraction.
Or zero overhead abstraction.
And people are beginning to take me to task for that, because that's underestimating and understating the ability of the C++ compiler. We can do negative overhead abstraction.
You can.
What if I was really good at writing assembly and I had all the time in the world to write it? Could that?
If you had all the time to write assembly in the world, you'd write an amazing program that compiles for like one architecture. And then if someone else wants to come and write it, they can't. So.
How does that compare?
If you are very smart and you have infinite time, you can do better. By and large, we are not as smart as the optimizers anymore, and we don't have infinite time. So if we are smart enough, we can only do a small piece of code. And now the question is, did we get enough time to use our smarts? This is even starting to affect clever code.
Also, just say, not to mention, being smart doesn't mean you can write assembly. That just means you can like keep track of states in your head very well, right? If anything, being smart would be your ability to take abstraction and make it useful, right? Like to think about a problem abstractly so that you can solve it using abstract tools, which are therefore also useful to other people, so you can explain it to other people, and then it's just more transferable to other systems. Like writing assembly, although like it takes, intelligence to write it, a lot of the actual process of writing it, once like you've learned how to do it, it's just tedious, right? Like I feel like once you've mastered assembly, the natural thing to do for a curious mind would be to then just move to high abstractions, because you're like, well, I understand it, but it just sucks to write it. So like I'm gonna try to make it easier. And oh look, that's where C comes in. Oh look, now we're at C++. Oh look, now we're at Rust. Oh look, now we're at like you know what I mean?
I gave a talk to Slack last year, which is a group of very performant, interested people from the finance industry. And my title was Don't Be Clever. Actually, the written title was Don't Be Too Clever, but I can't pronounce parentheses. And I got out alive. And my main point was that C++ is good enough for more than 98% of your code.
My issue is that clever is just misused. Like, really, we should question what we even consider clever. Like, writing this really obfuscated code that has a really cool optimization, like, is that clever? Or is it just the opposite? Like, if it's genuinely useful, then that's really cool. But then, like, you shouldn't just, but like, you wouldn't look at that and say, this is awesome. I want to put a ring around this. Like, no, like, you would acknowledge, well, okay, I managed to do this, but it wasn't really in a good readable way. So I want to see if I can find a way to make it more readable. Even if that means designing a language that can do it better. Right, like, again, like, talking about Andrew, fucking hell, what's his name? I know his name, I just forget names when I'm talking about things. which is hilarious. Oh my god, bruh. Who made Zig? Andrew Kelly. There you go. Andrew Kelly. Andrew Kelly looked at other languages. He looked at how they don't really... Well, because like he has this idea. I mean, I don't know if it's his idea, but like he has this obsession, let's say, with data-oriented design, where there's appreciation, there's understanding of it, and so he created a language that can just be better at data-oriented design. You know, rather than like write horrifically obfuscated C, he said, you know what, I want to make a language where I can abstract it and just do it more easily, and it's Zig. You know, it's great. That
so
is
if you want time to be
clever. Being smart.
You use these techniques, and I showed modern C++.
Being resourceful.
And that way you get time so you can do all the clever optimizations. The problem is clever optimizations these days tend to be machine dependent.
Yeah.
That is, if you get a new computer or if you get a new version of the compiler, you might actually have pessimized your code. I've seen this repeatedly ever since the
Is that clever?
The 80s, and there's people who does nothing but using different optimizations on the next generation hardware. And my standard techniques for improving things actually is to first throw away the clever stuff and then see if you run faster or slower. Usually you run faster because clever stuff tends, at least 1990s style clever stuff, which is, there's a lot of it still today because the techniques carry on in people's heads and some of the code remains, tend to use a rat's nest of pointers. And that gives the compilers and optimizers problems. They also sometimes use more allocations, which is not good. You want to minimize memory access, you want to maximize your cache performance and things like that, and compilers are getting very good at that. And I have seen this kind of thinking. I wrote a paper about it together with a friend of mine in Spain doing fluid dynamics. Damn. And we threw away the clever stuff or actually a performance test suite example, so it was not toy. And we got only 20% improvement by reducing the code to about 80% of what it was before. And so some people didn't think that was significant. I thought it was a significant proof that the technique was appropriate. You apply optimizations only when you need them. Knuth says don't do premature optimization, but he also pointed out that 2 to 3% is where you should optimize, which is exactly the number I'm using. And so first build the stuff using high-level facilities, see if it's good enough, and if it isn't, and you have to time it, you don't guess, you time. Then you figure out where the time is spent, and then you optimize that. But a lot of the time you don't need to go to that stage. It's fast enough.
I'd also just add there, don't spend your time optimizing code for your projects. If it's that important, rather than create a whole new programming language, because I did say that, you can also do compiler development, like contribute to compilers to make them more efficient. You could do that. That would be clever and extremely useful to everyone. So, hey, there's another idea, right? Yeah, premature optimization. It's a topic that always comes up. I remember when I was working on my library for converting a video game format called XFBin to JSON format. It was really slow, I found, because it turns out that the JSON library I was using wasn't incredibly fast. I was using Nolohman, however you pronounce that, NLOH man with 2 N's, .json, or slash JSON, whatever. His library isn't the fastest, so that's why I came to learn about like simmed JSON libraries. So that is one thing on my mind. I haven't like gone back to that project yet. I haven't gone back to that project yet in C++, so I haven't like used it, but it's definitely on my mind, having simmed there. And I have used it a bit in Rust. Another thing was I realized that my fucking regex was incredibly slow, and that's because my C++, sorry, not my C++, C++ full stop, has notoriously slow and terribly implemented regex, apparently. So that sucks. But I only knew that because I literally profiled it. I timed it and I saw what stages were taking the most time. And it turned out that although the JSON parsing was slow, you know, the slowest was the regex. I was just like, well, shit. I guess I need to not use regex then. Or like use a different regex library. So, you know, but like that's fine because like then I learn and then I know for future. But like the importance was definitely profiling there and timing it. Like he said, don't guess where the mistakes are, where this one is. Because like initially I did guess and I was like, okay, like maybe it's like this part of the code, like where it's parsing. I was like maybe it's JSON. So like I did everything in my power within the library itself. You know, that library for JSON to make it more optimized and like to use as efficient as possible. And then I actually did profile it and I was like, oh, I guess the JSON actually isn't like it was like slow, but it wasn't like the biggest slowing thing. The biggest thing was the regex, and then I realized shit. So now I know. Yeah. What was it about? Abstraction. And like abstraction is just useful. Like computers get better, computers get faster. You know, like that shouldn't be an excuse for writing lazy code. But it's more just that you don't optimize until it actually becomes a problem. Like don't create false problems, you know? And then once they do become a problem, like also with premature optimization, you become obsessed with perfection, and that can really hinder your development, like to writing code full stop, because like you might get stuck onto something like making this as perfectly optimized as possible. Whereas if you only optimize when you need to, and similarly by the way, like if you only abstract when you need to, so like be conservative with both optimization and abstraction, because perfection can send you down a terrible rabbit hole. But if you are conservative with both and only do them as you need them, then you save time, which is really good. You get to so you don't get stuck in the perfection loop. And when you do actually end up needing to add abstraction or add optimizations, you learn that for future. So then if you need to do a similar thing again in the future, you know that, okay, well, I know from my previous experience that if I write it this way, I'm going to need to optimize it later. So now that I know that, then I can do the premature optimization, knowing from past experience that it does actually matter. Right? Like, let's say, like a very easy example. Let's say you pass things by value all over your code, and then you realize, oh, it's really slow. How to speed it up? Maybe you get some feedback from someone else or an AI, and it tells you, yo, what the fuck are you doing? Pass my reference. So then you pass my reference. You know, like obviously, like you're not gonna like now, like only just only pass my reference when you need to. Like, you know, you're gonna say, oh, okay, well that's pretty easy to do, so I'm gonna just do that from now on. And then there you go. Now you use references in your programming. Like, it's not premature optimization at that point. It's just like good practices that you've learned. That's good. Especially when the language supports it and makes it easy. There's some optimizations where the language doesn't support it so much, to the point where if doing an optimization makes your code hard to maintain, that is an issue that requires better tooling and better languages. So again, if that is a real big issue for you and a recurring one that you can't seem to fix, then maybe you should focus on making better tooling by either contributing to the compiler development, or maybe in the most extreme scenario, making a new programming language or designing a new programming language. or even just like submitting a proposal for a feature. Like these are things that you can do. And doing those bigger things, like making a language or proposing a language feature or helping with compiler development, those, if you do those, you'll be hailed as way more smart and clever and intelligent and awesome than if you just like kept doing the same fucking thing in your projects, like as if you were smashing your head against a wall, So that's my take on that too.
I see. So when you say cleverness here, it's like human level, a manual management to eke out performance.
Yes.
And you're saying that actually, if you don't do that, you're giving the compiler more to optimize, and it can do a good job.
Yes, and it's much, much better than it used to be. Code that was cleverly and correctly optimized in the 1990s are often pessimized today, because machine architectures have changed.
Yeah.
And the compilers have improved.
When I look...
Alright, I'm gonna stop there, because my clock's ticking and I need to go soon. I did say I was going to finish this video and do my notes and stuff, but I don't have time for it. I mean, look, it's already 10:42, but I will continue this tomorrow. I also didn't really take that many notes. I took this, right? That's fine. I mean, I know I talked a lot about things as well. I could write down the things I'm saying, but to be fair, I don't really feel like I need to add them to my Zettelkasten just yet. Yeah, that's fine. But yeah, yeah. So I'll come back to this later. Consider this part 1 of a longer part video. But there you go then. Yeah, subscribe to see the next part of this video if you're interested. And also, just like a little side note, especially since this video is a bit short. Well, it's shorter, not really. But if you've watched this far or skipped to the end, whatever, in the comments, if you have a particular video you'd like to see me watch, particularly in about programming and C++ or something, like maybe not C++ or maybe not even like programming, but like something like computer science, maybe something like psychology related, something you think I'd find interesting based on what I've made videos on already, then drop a comment, because I haven't had any comments like that yet, where people suggest things to read or watch, whatever. Obviously within reason, like I'm not gonna fucking do like an entire book, but I might start a book. So yeah, let me know, and I might have a look at that.